Weather and climate-sensitive industries account for about 1/3 of the U.S. economic output. Climate cycles like El Niño can greatly affect regional temperature and precipitation, inundating some regions while inflicting drought on others. Drought causes billions of dollars of losses each year. Continuous, global, long-term satellite observations of weather patterns by the next generation GOES-R weather satellites will give scientists new insights into climate variability and climate change. Researchers will have better data for studying linkages between climate and weather patterns, resulting in better forecasts of extreme weather events. Geostationary GOES satellites have significantly increased our understanding of the relationships between climate variability and change, regional weather trends, and extreme weather events. To quote the Intergovernmental Panel on Climate Change Synthesis Report of 2007, based on satellite observations since the early 1980s, there is high confidence that there has been a trend in many regions towards earlier greening of vegetation in the spring, linked to longer thermal growing seasons due to recent warming. Geostationary satellite observations have, however, lacked the spectral coverage and radiometric accuracy needed for a more detailed and longer-term survey of certain key climate variables. Accurate observations of global sea surface temperatures, for example, can only be provided efficiently by satellites and are extremely important for the improvement of regional forecasts linked to climate variations such as the El Niño-La Niña cycle. Changes in atmospheric aerosols, pollutants, and trace gases like ozone and water vapor have important implications for both global climate and changes in regional weather, so monitoring them is vital. The next generation GOES-R satellites will complement polar orbiting satellites to provide a more accurate and complete temporal and spatial view of water vapor, precipitation, surface temperatures, radiation, and other key climate parameters. Only the GOES satellites can, for example, describe the diurnal sea surface temperature warming that occurs under light wind and strong solar heating conditions in the Western Hemisphere. Continuous observations from the GOES-R Advanced Baseline Imager, ABI, and Geostationary Lightning Mapper, GLM, will help resolve diurnal and seasonal cycles closely linked with climate variation. The GOES-R, ABI, and GLM will provide nearly continuous, calibrated, and accurate observations of climate parameters linked to the cryosphere, precipitation and hydrology, surface temperature, aerosols, pollutants, and trace gases. The ABI's high refresh rate will provide more opportunities to obtain visible, near-infrared, and infrared observations that are not degraded by cloud cover. It will also serve as a calibration anchor for the constellation of NPOS and METOP satellites. GLM observations will aid in monitoring regional nitrogen oxides and ozone concentration changes caused by lightning. Long-term flash trends will allow researchers to study the relationship between thunderstorms and climate change. With ample climate information, we can continue to extend our knowledge about climate change and its effects on the Earth and human systems.